Habitat Restoration Center of Expertise. I also just wanted to say thank you to the Coastal Zone Canada Pacific chapter for having me and everyone who came to listen. I would like to start by saying I'm really fortunate to live, work, and play in the traditional territories of the Cowichan tribes and Malahat First Nations. And so for those of you who know me, I did 17 years in consulting, and then about a year ago, I had the opportunity to get my dream job, some may say. I definitely say, doing exclusively coastal geomorphology with DFO, focusing specifically on salmon habitat restoration. So today we're going to cover an introduction to some of the fundamental concepts of geomorphology. We've had some previous conversations with the CZC members. The members in the audience all come from a really wide variety of backgrounds. And so the community of practice leads thought this would be a really valuable exercise to kind of break down some of the fundamentals. Not everybody's geomorphologists and coastal engineers to understand the intricacies of coastal geomorphology, which is quite complicated. And I love talking about geomorphology, so obviously I agreed. And so opposite to the recent webinar put on by the Atlantic community of practice looking at complexity of shoreline modeling, this will be a high-level discussion, definitely a bit of a different context, a high-level discussion of some of the basic coastal geomorphology concepts that are really integral to shoreline restoration and nature-based shoreline kind of design. And then obviously there'll be a little bit of a lens from my current role at DFO looking at salmon habitat restoration. Okay, why is that not? Okay, so let's start with geomorphology. What is geomorphology? Let's break down the word. Geo, earth, morph for change, and ology, the study of. So how do the physical features of the surface of the earth change over time? In a more simplistic way, geomorphology is the study of landforms and landform evolution. I get that question a lot, so I feel like it should be. And so what is coastal geomorphology? Coastal geomorphology, by definition, is the study of the morphological development and evolution of the coast as it acts under the influence of various processes like winds, waves, currents, and sea level changes. Fundamental to coastal geomorphology is an understanding of something called the littoral zone, which consists of a part of the coastal environment influenced by wave action where there's significant sediment transport exists. So a littoral cell is a coastal compartment that contains a complete cycle of sedimentation, including sources such as streams and sea bluff erosion, hence the term feeder bluff you might have heard, which essentially translates into the bluffs feeding sediment to the shoreline. Waves erode the toe of the bluff, causing instability. The slope of the bluff experiences some kind of failure, and then depositing sediment onto the shoreline where it's available for longshore transport. I think the stream component of a source is fairly self-explanatory, so I won't go into that. But also counter to this, just as a note, protection of bluffs to minimize erosion and stabilize slopes in source areas reduces sediment supply to the shoreline, resulting in sediment supply deficit. This affects the sediment budget of the transport and sink zones, which ultimately displaces the erosion to other parts of the littoral cell. Transport pathways. The usual transport path is alongshore by waves and currents, but can also occur as a cross-shore path, moving sediment on and offshore. We commonly see cross-shore movement during seasonal fluctuations here in the Pacific Northwest. For example, in the wintertime, larger waves move sediment offshore, creating the impression that a beach is eroded. And then the following summer, those smaller waves move the material back onshore, actually balancing out the sediment balance. And then sinks. Sediment sinks are usually offshore losses to submarine canyons and shoals, deposition in bays and estuaries. And so the cell boundaries delineate the geographical area within which the budget of sediment is balanced. So i.e. your inputs are equal to your outputs. And so providing the framework for a quantitative analysis of coastal erosion and accretion. So next, I'd like to introduce some geomorphic landforms that we commonly see in shorelines here in the Pacific Northwest. Three main features consist of deltas, beaches, and embayments. River deltas, which are formed as rivers release their sediment at the interface of a larger body of water, i.e. a lake or an ocean. Deltas can further be categorized into alluvial floodplains, which are dominated by river processes affecting their shape and form, and high tide flats or low tide flats, which can either be tide or wave dominated. Beaches, such as barrier beaches, where sediment is accreting seaward of a previous shoreline, and they consist of a berm or backshore, a beach face, and a lower tide terrace or shelf. Barrier beaches can also create a lagoon in behind the beach complex. A beach bluff consists of a bluff face as the main source of sediment, followed by a berm, backshore, and beach face. Embayments, people are like, what's an embayment? It's just a fancy word for bay or inlet. These can be estuaries or lagoons, and estuaries are an interface between freshwater and the marine environment, whereas lagoons are marine dominated. And then rocky coasts. Pocket beaches are present between rocky headlands, where sediment is typically limited. And so when conducting restoration or planning for coastal resilience, identifying the landform type and the dominant forces along that shoreline are really key in identifying how to restore or maintain a shoreline, what features you need to construct for it to function as naturally intended, obviously given current and future conditions, i.e. climate change. So I wanted to give just a little summary kind of conceptual model. This is Cowichan Bay. So now that we've learned about littoral cells and basic coastal landforms, let's discuss forcing factors controlling coastal development. So most of these are meteorological or oceanographic in nature that move sediments, which include wind currents. And as Dave pointed out, we all have these same icons. Wind-generated waves and swell. Wind-generated waves are waves that are generated locally due to the friction of wind across the ocean or lake surface. A lot of you are probably, or maybe have heard the term fetch, but aren't familiar with it. Fetch is essentially the length of water surface that the wind is able to interact and is a direct influence on the size of wave that's capable of being built based on those wind conditions. Wind-generated waves that were generated far, far away, other side of the ocean. We don't get them on the east side of Vancouver Island. We do get them down the Strait of Juan de Fuca. But basically, when they're generated far away, they travel across the ocean, separate into what are called wave trains, and then you get the nice, pretty, evenly, consistently breaking waves on the shoreline, like you see in Tofino and places imagery like you would see in California. So we obviously don't get those at this specific location. And then just more locally generated wind waves are considered or are much more chaotic, which is what you would see if you were looking at the surface of a water and windstorm. But talking about waves could be several university classes, masters and PhDs. So we're just going to leave it there. Water levels, which change due to tides, sea level rise, and storm surge. We have freshwater currents from rivers. Other geologic factors include the local geology and structure, which would include bathymetry and topography. And then sediment supply from rivers, and then, as mentioned, feeder bluffs and offshore sources. So also anthropogenic influences, which include changes to the shoreline, like dikes, riprap, seawalls, just to name a few. And any changes to other factors, so like river discharge can be affected by water license extraction. Sediment supply from a river can be affected by dredging. So any disruption to these natural processes. And then as well as the effects of climate change, that's also impacting these natural processes. Water temperature, changing levels of precipitation, which directly impact river discharge and sediment loads, variation in the intensity and frequency of storms, which can impact the size of waves, and the duration those waves are acting on the shoreline. That's a very important component to shoreline processes as well. and then increased water levels due to storm surge. And so this image is from Cowichan Bay on eastern Vancouver Island. So let's zoom into the site a little here. We are going to look at, in detail, a little site called Hecate Park to discuss how these processes are affecting the shoreline. And so this is a slightly zoomed in view. We're going to get a little bit more in depth in a minute of the shoreline and our site. Site is still exposed to wind and waves that originate from the east-southeast. But due to wave refraction, a mechanism that occurs when ocean waves approach a shoreline, a coastline or a shoreline, and there's a change in the ocean floor's depth. As those waves encounter variations in the ocean floor's contours, their speed and direction change, resulting in bending. I'm sure lots of us learned about that when refracting through different mediums, with the prism in physics class back in the day. So water waves actually do this with interaction with the bed. This is known as refraction. Typically causes waves to align with a shoreline as they move closer to said shoreline. So hence why these waves probably were generated in an east-south, or dominated waves in this location are generated in an east-southwest direction and then are refracted around to approach the shoreline a little bit more perpendicularly to its contours. However, sediment supply at this location has been blocked by longshore transport from the east due to the presence of a breakwater protecting the port of Cowichan Bay, and from the Coxsila River to the west due to the presence of what used to be a historic log dump facility and is now a park and kayak launch. So let's zoom in a little bit more and take a look at the site specifically. And so you can see in this picture, the shoreline at Hecate Park is completely disconnected. They're with an armored parking lot and storm sewer discharge to the east, a park and a kayak launch to the west. Previous attempts at renourishing the shoreline resulted in all of the sediment being transported to the west side of the park, and the forcing currents from, and because the forcing currents from the waves are still present. And these pictures are images of the shoreline at Hecate Park. You can see some large cobbles in the picture to the right, suggesting that this shoreline is exposed to moderately high energy waves for East Vancouver Island, that is. So one of the things geomorphologists look at when we go to a site is we look at the size of the material on the beach. If it is natural, like it hasn't been placed, there's no riprap, there's not, you have to be careful of people, some people add sand to their shorelines. I live on Shawnigan Lake. That's common practice here because people want nice sandy beaches. And anyway, so we look at the material on the sides of the beach, which can be an indication of the amount of energy, otherwise known as the size of the waves that the shoreline is exposed to. So here with the cobble may suggest a very high energy beach, but due to the presence of some smaller material, it's more likely that it's sediment starved. So that the presence of the cobble on the beach, the majority of fine grained sands and gravels have been removed, and the cobbles are kind of a self-armoring that's existed on the beach as an after effect. What you can't really see, the eastern side of this beach, close to the little orange building in the picture to the left, is actually quite fine-grained sand, silts, and clays. And this is because this little corner is protected by the dominant wave action by that armored storm sewer and the parking lot. So it's creating an area of lower energy exposure, which allows for the deposition of fine-grained sediments. One thing I'd like people to keep in mind, which is, I've had this conversation 1,000 times with people who are, not engineers or geoscientists. If the shoreline isn't a marsh or wetland, which are typically considered to be deposition zones or sediment sinks, if we want to keep with the terminology of our littoral zone. And so sands, gravels, or larger sediments, if they are sands, gravels, and larger sediments, it is likely that they are constantly moving. So if the beach stays the same size, the beach profile, and doesn't change shape, it means it's in something called dynamic equilibrium. So the amount of sediment in is the amount of sediment out. But just to reiterate, the dynamic part of dynamic equilibrium means that it's moving constantly, whether it's onshore, offshore, or longshore. Those sediments are moving constantly. I think that's a really important concept. People look at something, they see that it's stable, it hasn't changed over time, so they assume by stable it's not actually active, but beaches are active, high energy zones. This image is from 2022. So the objectives of this shoreline, the restoration to the shoreline, was to improve habitat for forage fish, which this was historically, and the undeveloped sections of, Cowichan Bay to the east and down towards Cherry Point are still forage fish habitat, and to create some recreational land use as well. The former cobble beach apparently didn't cut it. So in order to add the appropriate size beach material for Pacific sand lance and surf smelt, which are the two common forage fish species along the undisturbed shoreline, two small rocky headlands were built to trap the sediment into a series of pocket beaches. So always from a nature-based shoreline solution, this is a bit of a hybrid approach. Rocky headlands, rocky man-made headlands are obviously not a natural feature, but in a sediment-starved situation like this, being able to contain the sediment within these pocket beaches leaves the sediment on the shoreline for longer, so continued renourishment isn't required as often, which is obviously important from a financial perspective. And so the nourishment occurred in 2016 and 2018. And you can see here in this 2022 image, a series of nice pocket beaches are still present. And so the sediment is staying relatively local. So this is a bit of a different environment. This isn't a relatively protected environment. This is Esquimalt Gorge Park, which is in the gorge in Victoria area near Tillicum Road. You can see in these images, the park isn't a huge, it was only about an 80 meter across the 80 meter long beach, and then a 70 meter section of creek that we are going to restore. So the left image shows, in the foreground, seawall and trail, so hardened shoreline, grassy backdrop to the beach. You can see an obvious erosion scarp there, which is a small wave cut notch, and then a relatively gentle sloping kind of sandy silt beach. What you can't see in the background of that picture is the creek mouth, which is actually in the image on the right. This was a daylighted creek, Esquimalt Creek, or it's called Gorge Creek, sorry. And when it was daylighted in 2006, it was armored fairly heavily on its banks, which is obviously not very natural, and really disconnected with the riparian. Previous attempts at riparian planting have not been very successful, so the intent is to restore the shoreline for forage fish and rearing habitat for juvenile salmon. So this is an image of the kind of geomorphic conceptual model for the site. So you can see the purple polygons. Those are, decreased sediment supply zones because it's armored on both sides with a seawall. Anybody that's walked along the gorge, I'm sure you know the North Shore shoreline of the gorge is fully armored with a walkway as well. You can see the stream outlet down to the lower left, and then there's a storm drain right beside it as well. I should mention that you can't see in this picture when the stream was daylighted. They also put in a sediment retention feature in the middle of the stream, and that's to retain sediment because it's coming from mostly an urban landscape. It's contaminated, and so they wanted to retain it and be able to remove it on a regular basis so it didn't obviously didn't contaminate the nearshore water, but in the process is causing a sediment deficit to the already really limited shoreline. there isn't a huge amount of sediment in the system to begin with. There's a lot of rocky bedrock outcrops within the gorge, but the small amount of sediment that does come in via the stream, most of that's retained in the sediment retention feature, and anything that comes through the storm drain, usually during periods of high flow, is just shot out or builds up in, you can kind of see there's a, I don't want to call it a spit, but it's kind of, yeah, a sediment feature to in between the stream and the storm flow, storm drain flow. Interesting thing about that as well is it's contaminated, so won't be doing anything about that this trip. I should also say that the dominant wave direction and climate is fairly benign, with waves of maybe 0.3 to 0.5 meter as the, you know, kind of extreme max significant wave height in the wintertime. And so this is just starting to bring it in a little bit to into the salmon restoration world. So this is what we're looking at in terms of doing restoration. This image is probably a little bit small, so not sure how well you can see it, but the intent is remove the riprap. There's going to be some regrading of the beach shoreline. Where the erosion scarp is, the intent is to pull the scarp back and create a more consistent beach slope. It's unlikely that the grass part is the natural shoreline. Provide some beach nourishment that's in the form of appropriate grain size for forage fish habitat. Significant riparian planting to provide shading, as we know, as we move into, as we experience more and more climate change. Significant riparian vegetation is really important to have cool areas for salmon for rearing. And there was also a project on the other side of the footbridge. So you can see there's a footbridge there that's associated with the walkway that goes over the creek. World Fisheries Trust has installed a number of dendritic channels south of the footbridge, also to provide rearing habitat and protection for salmon on this site. We were supposed to go through construction this year, but due to challenges with archaeology permitting, which I'm sure lots of you are going through that headache right now, we've had to delay until 2024. So yeah, looking forward to that. Also, just like I wanted to provide a couple more examples of some kind of conceptual models. So this is looking at the Fraser River Delta. This is the summary. Again, it's a little busy. I didn't have time to actually put this into an animated version that I could show you all of the different pieces, but essentially it's showing, so the Fraser River Delta has been built up over about 10,000 years since the last ice age left this area. And so you can see the black, solid black line is the outline of the Delta footprint. And then we have a dashed line that was the extent of the Delta 10,000 years ago. And then the dashed and dotted line is the extent of the Delta 5,000 years ago. So you can see how it's built up over time. Arrows, blue arrows being direction of water flow. Historically, 10% of the discharge went through the north arm, with 90% of mean discharge traveling through the main arm. And that also means 10% of the sediment supply went through the north arm, 90% went through the south arm. You can see tidal currents across the front of the Pro Delta. The ebb current is smaller than the flood current. So just based on those features alone, those currents alone, there is a dominant direction of south to north. It just happens that most of the wave and wind to this area as well is coming from the kind of southwest. So dominant transport direction is to the north. And so when we look at, this is a conceptual model of current processes. This was done a long time ago in support of a report for Sturgeon Bank prior to the development of the kind of sediment nourishment project that's going on there now. And so looking at the changes to the system, sediment discharge has changed significantly due to dredging. That's been slightly alleviated in more recent years, but historically they were doing a lot of dredging for what they call boro dredging, removing sand for aggregate uses. They don't do that anymore because of how that was changing the dynamics of the river, but they do still do significant navigational dredging. Water discharge, there was trifurcation, which was a river training feature that was put where the river is split into the north arm and the main arm, and that was done in the 50s, and it's directing 15% of the mean discharge through the north arm, 85% of the discharge through the main arm. However, sediment supply, only 10 or 15% of suspended sediment material is directed through the north arm, with 100% of the bed load now coming through the main arm. So you can think of how that sediment reaching kind of this delta front, how those dynamics changing. There's no more bed load coming to the north end of the delta. Obviously, the presence of the North Arm Jetty, the Iona Jetty, and then the Steveston North Jetty are all impacting how sediment transport moves along that stretch as well. So there's a significant reduction in sedimentation rates to the pro-delta. The main part of the delta is also subsiding at a rate of 1 to 8 millimeters a year. Couple that with the presence of dikes, limiting resedimentation of the delta plain, which happens during flooding. We've got a significantly receding. There's other indications as to why the delta was previously receding anyway. We won't get into those details, but just an interesting comparison of how anthropogenic influences have changed things like both water and sediment delivery to a fairly significant system. And so why is coastal geomorphology important to salmon? And so beaches, bluffs, estuaries, and tidal areas of the nearshore zone are important areas for salmon. All species of juvenile salmon from BC watersheds use nearshore areas to grow strong before heading out into the open ocean. Research links early life stage success to salmon survival rates, predominantly nearshore habitat, and also nurtures the food web in estuaries and offshore, providing sustenance for adult salmon and other wildlife. So nearshore habitat can take many forms: kelp, eelgrass beds, rocky or sandy beaches, tidal mudflats, lagoons and estuaries, and salt marshes. Overhanging riparian vegetation and sand cobble mix beaches are important elements, as we discussed, from the forage fish perspective in rearing habitat. And estuaries connect freshwater systems and provide resting spaces to migratory fish. And so why is nearshore important? Safe migration. Juvenile salmon are a tasty treat for many kinds of marine life. Natural nearshore environments can provide safe places for these salmons to hide and rest during their journey to the sea, such as in the eelgrass just offshore and the estuaries that connect to the sound. Estuaries also provide a gradient of salt and freshwater, which juvenile salmon can use to support their gradual physical transformation from rivers to oceans. The other key piece about another aspect of this is during this transition time, there's many current anthropogenic features that we've put in our rivers. So by confining them with dikes, causing them to be, more single channel confined spaces, it's really easy for predators to prey on those juvenile salmon because they don't have anywhere to hide. Places where there's tide gates, where salmon need to wait for certain water fluctuations in order to enter some of the freshwater systems for spawning. They're basically just waiting grounds that seals and other predators can sit at and pick the salmon off. So it's just It's very, very key to have these natural features available so they have protection. A critical or buffet for a critical time. So sea wrack on beaches and overhanging vegetation from shorelines and trees and bushes provide nutritious insects for young salmon to eat. So this is so significant in, we look at riparian vegetation on shorelines, and there, in many scenarios, there isn't any. And so that's one of the key challenges by having no riparian vegetation in our nearshore environments. It's really limiting the amount of food available for young salmon to eat. And so it's much more likely to be available on natural shorelines where vegetation is still intact than on heavily armored shorelines. There is a rule: you can't put riparian vegetation on a dike. How many shorelines and estuarine channels are diked? Obviously, particularly in the Fraser River estuary, it's the largest salmon-bearing river in Canada. There's so many reasons why it's an important estuary, and it's completely developed. So estuaries also flush nutrients from marshes into the nearshore, which supports the forage fish that adult salmon eat on their return trips to spawn. Many other species also benefit from healthy nearshore habitats and food webs as well. And then so also forage fish spawning, which we talked about with some of our kind of restoration examples. Tidal flats of the nearshore are spawning habitat for forage fish. Small fish species, including herring, sandlance, and the surf smelt that serve as the basis of the food web, are essential food source for adult salmon. These fish spawn either directly on sand during high tide or attach their eggs to eelgrass just below the waterline. Adult salmon, birds, and marine mammals eat these fish. Their populations are critical for salmon and ecosystem health. So this is going to take you the next section. Many of you probably have not heard of the PSSI, or Pacific Salmon Strategy Initiative, and so that's the part of DFO that I am a part of, or the Salmon Habitat Restoration Center of Expertise, which is our team. And so I wanted to give you a bit of intro. And so it was developed by DFO Pacific Region in response to Pacific salmon stocks across BC and the Yukon. So the Pacific region covers all of Yukon and BC, just in case anybody didn't know that. Facing persistent and severe challenges, despite reduction in harvesting of stocks of concern over the last decade. Pressures on salmon include climate change, pollution, habitat degradation, fishing pressures, land and water use pressures, invasive species, disease, pathogens, et cetera, et cetera. So in 2021, the federal government pledged $750 million for this program over 5 years. And we're currently midway through year 3 of 5. And so the PSSI is a multi-pronged approach that represents an organizing framework for a comprehensive set of activities to address habitat, hatcheries, and harvest-related measures to implement a series of immediate and long-term measures under 4 pillars. So conservation and stewardship, salmon enhancement, harvest transformation, and integration and collaboration. My team falls under the conservation and stewardship pillar, but is only one small piece in the much larger framework of people working to save salmon in the Pacific region. And so within the Stewardship Directorate, the Resource or Restoration Center of Expertise was established to strategically direct and deliver salmon habitat restoration activities and to provide technical and scientific expertise to support programs and external groups. There are 2 sides of the restoration COE in the organization chart, which you can see here. Left is what's known as the regional teams, and on the right are the area-based teams. It's the intent of the regional-based team, and so the regional teams are all new. The intent of the regional teams is to provide both administrative, operational, scientific guidance, innovation, planning support to the area teams who are on the ground implementing restoration projects. Area-based teams are broken up in the Pacific region into Fraser Interior, which is the entire Fraser River watershed, North Coast, South Coast, which is Vancouver Island, Sunshine Coast, and Yukon Transboundary. And this is me and our team on the operation coordination support side of things. And so the intent of the COE is to bring much of the specialized expertise required for restoration in-house and expand our capacity to advance restoration through the following goals: building and maintaining relationships, promote, support, and implement coordinated restoration work in priority areas, and develop and implement innovative and effective science-based restoration. So some of the ways that we're doing this, some of the stuff that we're working on now, keeping in mind that most of our teams have just been fully staffed in the past year. Just the capacity hasn't been there until this year. And so some of the ways we're doing with the creation of a restoration priorities plan, development of a database of restoration work so we can identify where restoration work has already been done and maybe areas that could use more, effectiveness monitoring of existing and novel restoration approaches to guide future restoration decisions, and then through the testing and implementation of innovative methods for restoration. So that's just a small piece of what it is that we're doing. And so the plan is really to take restoration into the future to maximize the benefits for salmon while reducing cost and time to advance on the ground projects, consistent implementation of projects, and improved information and knowledge sharing on restoration research, best practices and techniques, including the incorporation of Indigenous knowledge and cultural values. And so with previous iterations of restoration within DFO, they were called the former Resource Restoration Unit, or RRU. They were really limited in both capacity and funding. That also vacillated depending on who was who at the political representation of the time. And so the extent of what they could contribute to was fairly limited in the past. So with the newly formed COE, the intent is to increase DFO action, participation, and contribution to the field of restoration. Our team includes experts from the fields of biology, ecology, engineering. We've got engineering and monitoring technicians, geomorphologists, data analysts, lots of, and no offense to the consultants in the world, it's a little cheaper to have expertise in-house rather than charging it out. So some of the work that we're doing at the moment, just to highlight a couple of quick key projects. Anybody in the Lower Fraser mainland area maybe have heard of the Squamish Spit removal. It was 800 meters of a river training structure that was removed to reconnect the Squamish River with the Squamish Estuary. So the picture on the left is during a low tide where they're out doing some planting, and so the intent and hope is that will all become marsh habitat. The Mamquam, which is a tributary to the Squamish, doing a geomorph data collection. It's me on the phone, on the computer in the corner. One of the innovative projects we're doing is an eelgrass seeding project. Historically, eelgrass has been planted by plugs. It's both very labor intensive and costly. The eelgrass seeding pilot method is hoping to provide increased genetic diversity to an eelgrass plot. But it's also less labor intensive. So we're looking at success of that project. Jacobson Creek, which is a tributary to the Fraser, instead of using riprap, they're attempting to use bioengineered bank stabilization using coir soil wrapping methods. We do have some intent to find some projects where we can try this type of technique in a salt marsh environment as well. I talked really fast through a lot of that, so I think I'm a little bit early, but I just wanted to say really thank you for listening. Stay tuned as DFO and the Pacific Salmon Foundation will be hosting a nearshore restoration knowledge exchange in late January, so I'll share that information with the Coastal Zone Canada team. And then just also wanted to mention that, while we're doing this from a salmon restoration perspective, when we're looking at nearshore or nature-based solutions, particularly in the face of climate adaptation and resilience, the opportunity for co-benefits, looking at restoration benefit, habitat benefits, as well as the coastal resilience piece, I think is really, a really crucial way in moving forward. So, yeah, thank you so much for joining me today, and I'm here to answer any questions.
Thank you, Morgan. That was awesome. And yeah, really a nice blend of hearing what you guys have been up to and getting that center off the ground and running. And I think a really awesome background for a lot of people who haven't had that exposure to geomorphology. Does anyone have any questions? Feel free to raise your hand or put it in the chat. I mean, one question I kind of have for you, Morgan, oh, Phil, you want to jump in? Please go ahead.
No, you go ahead. Now I'll wait till you're done.
I was going to say,
maybe you'll answer my question for me.
Okay. I was going to say, what should people do, or what kinds of projects are you guys looking to collaborate with? Like, should anyone interested in collaborating with your center sort of reach out directly, or are you targeting certain initiatives run by certain groups, or?
Anything to do with salmon habitat restoration, we can provide support. So it's not necessarily like you can use me as a free geomorphologist to write your coastal report. I don't have capacity for that. Neither does the team, but we can provide expert opinion, advice. We can connect you with other proponents and people on the ground. Our area staff are amazingly connected with local First Nations and other nonprofits for people looking to share resources and ideas. We've got a number of partners, et cetera, that we can connect with about interesting, and people within other areas of the government that are doing research-based work that we can connect. It's just always important. I'm always up for a chat. And if I can help, great. And if not, hopefully I can connect you to someone who can.
Perfect. Thank you. Phil, I'll let you jump in. You go first.
Thanks, Neville. And thanks, Morgan. Appreciate your presentation, particularly like your entry slides on sediment drift cells. I've seen that one before somewhere, I think, but that's good.
Somewhere.
The question I have is what tools should the geomorphologist bring to the table, and what's most needed from geomorphologists right now in terms of advancing how we deliver projects that enhance, make enhancements to habitat or improvements to shoreline resilience in general?
I think one of the key pieces is looking, and a big tagline right now is process-based restoration. It's in the freshwater environment that's being used quite a lot, and I think it really holds true in the coastal environment. And it's probably surprising that hasn't been common in the past, but I think the viewpoint that geomorphologists bring, looking at the connectivity of the entire system and where alterations to different components of those factors really can affect how it can affect a shoreline or a project in the grand scheme of things. So really looking at the interconnectedness of all those physical factors and features. I think that's really one of the key things that geomorphs provide.
Awesome.
Sounds like modeling.
That's one component. I mean, modeling, we can do sediment transport modeling. I think in some, and as you and I have experienced in our many years working together, there's, I think it depends on the level of complexity and the level of risk at a certain site to the level of detail you need to go. If there's potential risk for infrastructure, you're going to want to do something more robust to ensure that your ultimate intent in the restoration or nature-based solutions is going to be, robust in the long term or maintain its integrity. Whereas in some scenarios, you're in an area where you can there's a little bit more flexibility and fluidity that we're going to trial this restoration method based on field data collection and maybe historical analysis, just desk-based, but it doesn't need, the in-depth modeling piece, because that does add a huge cost component, and in a lot of scenarios we're financially limited in our options. Yeah.
Thanks.
Sarah Primo, I'll let you jump in with your question you have in the chat.
Hi, can you hear me?
Mm-hmm.
Yeah. Sarah Primo, I'm a landscape architect and ecologist with Space to Place. We're working on a number of shoreline-related restoration projects and adaptation to sea level rise type projects. We're in the process of preparing some drawings for DFO permitting, and we've got a number of projects involved with permitting, and I'm curious to know if there's any internal discussions happening at DFO for helping to sort of expedite permitting processes for these types of nature-based solutions, because up until now, like in the past 10 years, it seems like the projects typically go through a standard process, and it doesn't necessarily incentivize the nature-based solutions. So just wondering if you can comment on that.
Yeah, and as someone who is not in, like, the regulatory body is a very separate entity, I have been in discussion with, I do get contacted sometimes about things that if I can help from a coastal geomorphological perspective, provide some insight on whether they're viable options or not, or maybe suggest some additional questions to ask to provide, kind of the rationale or background research for some of these things. There is some plan to do a similar discussion with some of our FFHPP team on coastal geomorphology, so they've got a greater understanding of what to look for and what questions to ask, and then maybe down the road that would be, because I agree with you, I think that would be, it does make sense that if there's some restoration component to it, it would be nice to see a more streamlined process. And I do know that with, at least with the Green Shores, there has been some work on the provincial side with getting some of those permits in the nearshore zone expedited, as long as they fall under a certain checklist for nature-based solutions. And so hopefully we'll be able to emulate something the same in the federal government down the road.
Okay, and we'll do a quick question from
Thank you.
Enda, and then we'll want to end with 3 quick polling questions. But I will say there's also a couple more great questions in the chat, and we'll chat with Morgan after and see if we can follow up on some of those. So thank you everyone for your interest and engagement. Enda?
Yeah, and we might need to take it offline at some point, Morgan. But I'm just curious if your teams are doing any work on 2 topics. One, the role or maybe impacts of driftwood on salmon habitat, given that, a lot of logs of driftwood in the coastal zone in the Pacific. And the other is, you mentioned forage fish habitat and that they like sandy systems. I'm just wondering if there's any knowledge or guidance on, gradations that are, most beneficial for certain types of forage fish spawning and things like that.
Yeah, absolutely. Okay, so first, driftwood. I mean, there's 2 lines. The benefit of large woody debris in providing habitat complexity and some stability along the kind of high water line in certain shoreline environments, and the benefits to that. There's also, because of the plethora of driftwood that we have in the system because of forestry, there's also an issue with large woody debris ending up and smothering salt marshes in large quantities. So there's like the good side and the bad side. And so we haven't necessarily had the chance to do research per se, but I do know that there is quite a lot of documentation of the benefits of large woody debris in riparian and nearshore zones. Obviously, we incorporate that into a lot of our designs. On the negative side, not necessarily as much, and looking at what kind of restoration options there are for depositional areas that end up with too much large woody debris. They're also usually like a salt marsh. You can't put an excavator into a salt marsh to remove large woody debris. So how do we clear that out and reestablish that habitat? Or is it a longer term looking problem? Is, do we think because they're ending up here and this is an ongoing problem, is there something else we need to do that's going to be kind of viable as a long-term option? Because the restoration isn't restoration if you have to go back every year and maintain it, right? But the ideal objective is for it to be like self-maintaining as much as possible. So looking at both of those pieces, but would be happy to connect and have some conversations and about research on those type of topics. So if that was like a volunteer
All right, I think we will wrap it up there. Thank you. I'm sure Enda and Morgan, you guys can follow up because that is an active and very interesting topic. I'm going to pass to Jamie, and we're going to launch just one polling question for anyone who was able to stick around to answer, and that will be it for us today. So thank you so much, Morgan. We really appreciate it, and we're thrilled you were able to come and do this today.
Yeah, my pleasure. And I mean, feel free if anybody is interested in I can put my contact information in the chat if you want to reach out, and I can either connect you to other people within my team or answer any questions you may have. Thanks so much.
Great. Jamie, over to you.
Great. So we'll launch a quick poll. Hopefully it should pop up on your screen, and if not, just reach out to us afterwards. The question is, if the Pacific chapter hosted an in-person session in 2024, which topic would you be most excited to engage with? Case studies of local projects, guidelines for nature-based solutions, or regulatory changes needed for nature-based solutions? Great, and thank you for your participation in the poll. Thank you once again. Please join me in thanking Morgan for such a great presentation, and thank you to all of you who joined us today. That wraps up our presentation. Please stay tuned for news about our next webinar. Till next time.
Thank you, everyone.
Thanks, everybody.
Perhaps I'll end with a joke if anyone's still sticking around. I was told that another reason that rivers have such high habitat value is because salmon keep their money in the riverbank.
That was a good one, Jamie.
I was gonna lead with it, but we were out of time.
I like it. Thank you.
Love it. I love it. I love a good pun.
Awesome.
There, is that a high five, or you will have another chat question? There we go. Okay. Thank you, everyone, for joining, and I will end the recording now.